Hi, this is the second week of tutorials for CartoGIS, and this is the QGIS tutorial. This week, we're going to look at two different approaches for making static maps, or rather two different scales of static maps. First, we're going to do this nice flight routing map at a global scale, and then we're going to look at some PPGIS point data from the Helsinki region. So we're working at a very local scale. Let's start off with this global flight route map. By the end of doing this tutorial, we'll know a bit more about layouting a world map, some tricks for doing that, projections. So keep working on those and the idea of how they will affect the outlook of your map. Then this map will be very crowded if we just visualize it as it is. So it's going to be a lot of overcrossing lines and a lot of points. So we're going to see some tricks for dealing with that. And then from a QGIS approach, QGIS specific stuff. So we'll keep working on data-driven styling. So there will be another trick for using this data-driven styling for your advantage. The dataset for this tutorial is from openflights.org. So basically it will be, we start off with a point map, and this point map will tell the location of an airport, and then we'll have information about connections between two different airports. I'll show you in more detail soon. And as always, you can download the tutorial data from these instruction notebooks. So you will find them on the web page, I think. But you can also, if you open them in Note or you open them in Binder, so you have this notebook itself. So the tutorial should be in this specific data folder here, or rather here. So for this week, or for this tutorial, there's only this one GeoPackage file called sources and destinations. I pre-processed it a bit from the raw text files so that we can focus on the interesting stuff, which is, well, working on the data a bit more and then on the visualization. Same as last week, we also have certain QGIS materials that are shared as a zip file. And these are the style files that if you want to replicate the style that you see on this tutorial, you can do so with this .qml files. And then there's a model file. So this can be inserted in the processing toolbox here. And then you can rerun these same steps that I'm going to walk you through now if you need to replicate something later on. So just reduce the number or amount of clicking. So you can just run this model file. Okay, let's get to the actual work. You have sources and destination GeoPackage in the data folder. Drag that into QGIS and start working. And you can see that there are actually two layers in here. So the GeoPackage files, as you may know, can contain multiple layers. So add both of them. And now I noticed that I have a funny coordinate reference system at work. So this is one that you would use for Finland. It obviously doesn't work globally. So you will want to change it to something more sensible. And for now, we can maybe take this basic VGS84 reference system. No, not that one. For now, we can probably take, this one. Yeah, so it's not great, but it suits us for now. So take a look at these source and destination layers. And as always, remember to check the attribute tables so you know what's happening. So each one has the identifier for that airport. And then there's a route ID. And these route IDs are the ones that connect the sources to the destinations. So here, for example, we have this Domo de Devo International Airport with route ID 3. We check the destination here. Yes, so then that connection connects to Kazan International Airport. It's this one with route ID 3. So if you look at this, what we have at our desk here, so it's actually just a point map with this default styling. It doesn't really tell us much, except maybe where on Earth those airports do not exist at all. We could make it a bit more sensible just by adding a world map. So it's a trick for everyone who's using QGIS. So if you ever need a quick basic world map layer to your project, so you can just select the coordinate field here and type world. And with that, I think that's a basic natural Earth vector type world map as a background map. So that's good enough for most purposes. So yeah, you can see where there aren't any airports, but of course we have to go further. And what we'll do is to make two different layers, derive two different layers from these points. One is a line layer, so we'll connect those sources and destinations to each other. And then we'll also enrich the point layers with the information of how many routes terminate at specific airports. And then you can use that information to style those point layers as well. So starting off with the route lines layer. So we can use just the basic tool called join by lines, uplines. And for that, we want to have up and spoke. I don't think that matters which is the hub process and spoke the destinations. Then remember we need the route ID route ID layer to connect these two. Then, and this is the more interesting stuff for this visualization, is that we want to create geodesic lines and remove this distance between vertices a bit. That just makes them smoother. And then split lines at anti-meridian, because otherwise it creates something a bit wonky. So just to recap what these geodesic lines are, they're great circle lines, so it tells the algorithm to draw the shortest path between the 2 points on the globe. So they won't look straight lines, of course, with this CRS that we have chosen, but they will be in real life the shortest path between these 2 points. So I'll demonstrate that a bit later. But if you have everything picked here, click run, and then you can expect this algorithm to take a good while, up to 6-7 minutes. So I'll pause the recording and get back to you soon. So now the tool has finished, and we have a new layer called hub lines. You can see it here. It's a bit of a mess right now, but indeed, as I mentioned, these are geodesic lines, so there's great circle lines. And if you want to sort of make sure that's true, you can always check a mnemonic PRF, like this lotball mnemonic there. Oh, we're, for example, checking out Finland. So yeah, now you see that all of these lines are great circle lines, so the straightest possible lines. Good. So what we want to do now is to think of what PSS both styling for this. So obviously, this sort of spaghetti mess isn't feasible. It's not something we want to do or use. So we'll do a few things. First, from layer styling. And by the way, I'm going to use this layer styling panel here. You can find it in QGIS from view and panels, and here layer styling. So with this, I don't have to open it from properties. It's the same options nonetheless. So let's reduce the width of line first. Yep. We'll add a lot of transparency. So you can even set it to like something like 5% to know the places that are where there are a lot of connections, so they will be emphasized, obviously, because then the sort of color is multiplied as there are multiple lines overlapping. And then the color in scheme, you can pick whichever you want. I'm going to use this sort of very white or gray color. I need to insert it here. So from this layer styling and color styling, I find always this HTML notation. We have this grayish color. Yes. So, okay, that's already a lot better than it was before. If you want something nicer, do keep working on them. And obviously this gray color works because I have a dark background here. Yep. So that's our lawn layer. Next, we have to do the count layer for the airports themselves. So how many flights terminate at each airport. And for that, we use a tool called aggregate. So this is a handy tool that basically tells the layer to take each column and do some sort of function for them and output something new. Like we group them together with something, and then for each matching for each group, we'll do some sort of function here. So you have to select destinations. Yes. Then destination airport. So this tells that for each role where this destination airport is identical, create a new group. Then we can remove its destination FED and name destination, for example. So we don't keep this ID for the airports and then route ID. Doesn't really matter, but yeah. And then for the airport ID, we'll keep the first value. So this basically tells that we just want to keep the sort of grouping value. So the name of the airport in there. And then for each route ID, we'll count how many unique connections there were. This you can rename route count. And that should be everything. Then you can just run this tool. So it's done. You have a new layer called aggregated. And if you check its attribute table, it tells you the destination airport ID and then how many routes terminate there. And if you can just do a sanity check whether this makes sense. So for example, yeah, Atlanta International Airport is the one that is in dataset as most terminations, 911. And I believe that makes sense because I believe that Atlanta is the most trafficked airport. At least it's up there. Then we'll think of the styling for this one. And here we use this example style. You can also find the airport style.qml. And what are the other ideas here is that we'll use the number of terminations as a feature to vary the size. So use the basic graduated functionality here, which count the size. Size from 0.5 millimeter to 3.5, and these were just ones that I found to be quite suitable. We're not looking for like exact information with it. This will be more so style than information first map, so it doesn't really make sense it's not necessary for the reader to exactly identify to which group each each of these airports falls into. Yep. And take these two extra layers from out of there. So now we have the size set working out. And next we can color them. And we could do, of course, multiple things here. We could color them, emphasize this information of how many sort of flights terminate somewhere. We could emphasize that with color as well. Or then we could do something completely different, like which continent this airport is in. But actually we'll just use something, or we'll just do something that looks nice. And we'll color them by this longitude value of the airport. And then we'll do that sort of smoothly with a data-driven expression. So from symbol and configure symbol, and simple marker, and then the fill color. So here we can sort of define by which of the function this fill color is defined. It's not this standard one that's given here. We can use this assistant here. And now it's looking for some sort of value. We'll provide it with its X geometry. So basically it says that for this geometry, for this feature, take its geometry and take its X value. These should vary from minus 180 to 180. And then we can choose a color ramp. I think I went with Viridis. Yes, and now it's overriding this standard fill color here. If we apply it, then we have this nice gradient from one sort of edge of the world map to another. But again, this is an arbitrary decision, and more sensible ones might very well exist. So now we have everything that we need for styling our map. So we done all the pre-processing, we done all this styling here. Now all there is to do for this map is to layout it. And I'll show you some of the thinking that went into my sort of layout here. So let's start the new layout. And a bit smaller. Yep. So first, this is something that I found out all the time, that for world maps, the standard A4 at landscape doesn't work with that one. So I want to reduce the height of it a bit before I place anything in there. So I put it to 160 centimeters, or millimeters rather. And then you can add the map. And just raise it a bit. In that scale so that it sort of shows what we want, but doesn't have too much useless empty space. Still a bit. Yeah. The thing about maps is that you can keep working on them endlessly and sort of fine-tuning every small thing. But at some point you just have to accept what you have. So then another important part of this map would of course be a legend. And I think we can do a bit better than this standard one. So for always these things, I like to deselect the auto update. So because it would just keep sort of returning the standard outlook. We don't need these in any of these layers in here. And even for this aggregated layer, as I mentioned before, we're not really that interested in showing exactly how many terminations are to each airport. We just want something that shows the relative value of each airport. So I think we can reduce these 10 classes quite a bit. Maybe just down to 3. Something like that. So just Deselect this one, then deselect these ones. Yeah, I put edit here, just place like minimum values 1. There's one that showed sort of that we have like a lot of values in between, and then the maximum value is 911. Good. Then these hub lines. So we could, well, it's good, maybe it's not necessary. I think we can indicate here that this is sort of rows, light, roots. So let's say it's so that it reads light roots. Then we can maybe remove this background. Then obviously we need to tune these fonts a bit. Something quite light, or even just, we can go with just white. Why not? On something more fun than the very standard font. So see if we have something like Arial. Yeah, why not? This is not an exact art. And then for the flight routes, we still need to fine-tune this patch a bit, or this symbol. So right now it's not really visible because there's so much transparency. But if we just set it like that and make it a bit wider, now we have something more sensible. To rename this class by like something like efforts by writing which will set the subgroup header to Arial and white. And now I noticed that actually I was supposed to have this line layer on top of the point layer, so we can just still return the actual one here and then just change there. But look, and now, yeah, it's updated here as well. So now we're emphasizing the flight routes. Obviously, there's a lot of transparency there, so you can still see the sort of structure of these airports and the width of them for some, but maybe not as well for Europe, for example. Okay, we have quite a lot of things here. We have a legend, we have so the layouting of the map, which is pretty standard world map. What we still need is a title. So we can do that in Arial. We'll add it quite a bit larger. Right. And name it global flight route then. About flight routes. And obviously a good practice, for example, of additional things. Now that we have the title, we still work on the placement of it, but some good additional things to consider. For example, a data description. So what are we using here? So we have the openflights.org dataset here. So that could be placed somewhere here at the bottom. On this map, we don't really need a scale bar, or it wouldn't really make any sense for this global map. We're done. So we are right about done with that for my tutorial. But of course, this is not a finished map. It's not maybe even excellent one. So I have some additional things here you can consider if you want to keep working on this, and I recommend that. And try out different things. So you could try out, for example, different colors for this lines. You could try out different colors for the airports and stuff. You can think of a different way to visualize this data. You can, for example, try cropping it to a certain region. So instead of doing the whole world, try Europe or try South America, for example. You can try what would, for example, adding these country borders that we had in the other layer. With that, add something here. And maybe the most glaring thing that I noticed here is that we have this standard VGS 84 sort of Mercator projection. So that's not really great. So you could try out a different word project, like a different projection, and then see how that affects the map that you have here. So like World Robinson, for example. Oh, obviously it affects this line maps that we have here. Yeah, you could try out different systems and different kind of framings and layouts as well. So with that, I still want to remind you that with these QGIS files here, with the folders, files that you downloaded with this tutorial, you will find this processing flow notebook. And if you go back to, so you go back here and want to open an existing model, you'll find it here with flight routes and airports. Then you can just run these, and you need to provide these style files. I need to provide the layer with this destination airport field and so forth. But with this, you can run the same thing without clicking through everything. So we're done with this. And okay, let's get to the second part of our tutorial. In it, we'll work with PPGIS data from Helsinki, so public participatory GIS data that's been elicited or it's been gathered by participants in a study. And you can imagine the task in here as let's say you're a data expert for the city of Helsinki, and you have run this study, and now you need to find a way to present it sensibly. So what would be the insights that you would try to get from this sort of point data? In this tutorial, we'll check out a few different ways of doing this basic point map, and then doing some processing of how different ways of further sort of developing that point data, such as aggregating it to a grid. And then to make the map further readable, we'll look a bit at labeling. And then from a layout side of things, we'll also check out inset maps, so how we can sort of get a wider overview of the location we're working at, since this is not now anymore a global but a local map. The data that we'll be working with comes from this Urban Happiness project at Aalto. It's publicly available from this repository, and there are a few different variables in it, but we are especially interested in this quality column because it gives us a nice positive or negative sort of binary value. So whether people perceive a certain place as positive or negative. There's a geo package that has everything we need for this tutorial. You'll find it, as always, in the files, and you can download it from the web page or on this tutorial notebooks. And by the way, if you want to download it straight from this notebook, usually the best way to do that is keep Shift down and then right-click, and then there will be a save to disk. So then that will download and save the geo package. There are a few QGIS files, again, as always, style files and model files. You know how it works. And as a prerequisite for this week, we'll also need a specific plugin called Quick Map Services. And let's download that right away. Of course, I downloaded it, but just go through the normal route and install it. Well, I can update it just to have an older version. Good. And we can actually straight away see how that works. So on this web drop-down bar, there you will find a Quick Map Services. And I can remember if by default, you might see a few options here, but these are all background maps. So pre-made, usually based on OpenStreetMap data, pre-made map views. If you don't see as many options as I do here, so you can go to settings, and then I believe there should be more services and get this contributed back. So I think that should add a few more options here. We can add CartoGIS and positron, which is this kind of nice neutral map. You can zoom into Helsinki. And here I already have a quick CRS for Helsinki, because by default I use EPSG 3067, which is the sort of recommended one from Finland. But if you don't have it, you probably don't by default, so you can select it by just filtering by 3067 and using it. Then let's add our actual datasets to use. So QGIS data, there are actually 3 layers in here. Add all of them. And you can now these, or maybe, yeah. So this Helsinki borders is just extract to OpenStreetMap the borders of Helsinki. And then there's the landmarks layer that we will use later for tiling. And then there is the actual dataset we're interested in. So check out its attribute table. And in here, you'll find the quality. So each of these is contributed by participant, that means PPHS study. And then you'll find the quality that they rated that place at a positive or negative. There's one thing to notice here if you have the Helsinki borders. So actually a few of these points are outside of the borders of Helsinki, and we are not interested in those. So right away, this data is a bit dirty. We need to clean it up. That's a very standard procedure. So extract by location and extracting from the experience points using these Helsinki borders. With that, we're left with all of the points that are inside Helsinki. And we'll keep working on this layer. So first, we'll just create a very simple point map that tells us something about the distribution of these positive and negative points. We already added this background map. It's helpful for sort of orienting us and making sure that we don't need to add an MC layer, for example, somehow get this sort of borders of Helsinki in here. We don't need to style it. Of course, if you want to create a map from specific purpose, you usually want to do that styling yourself, but this is good enough for our purposes right now, exploration of this data. So we'll keep working on this extracted layer, create our simple map. So let's see what happens if we just create a map of the positive and negative values using this categorized symbology. And remember, I'll be using this layer styling panel from here, view and panels. Quality, classify. It seems we have a bit of a trouble here. So actually, the data is also dirty in the way that both in terms of spatial distribution and then in terms of these attribute features. So actually, there's negative that are typed both with an uppercase and a lowercase, and they are construed as different entities here. So one way to fix it is just to updating that column in extracted location. So open a field calculator, update existing field and quality. So we'll use this function called title. So there's an explanation here. It converts all words of a single string to title case. So the first letter of it is capitalized. With that, we can just save those changes to the temporary layer. And now we need to reclassify everything. If we now select quality and classify, so now it's all fixed. So a bit of house cleaning first. Now let's get on to creating this map. So styling a bit, and here, of course, think that you're only representing like positive and negative values. So you might start thinking what would be colors to represent that sort of phenomenon. Intuitively, maybe you're thinking of red and green, and that could make sense, although it's problematic in the sense that it's not really friendly to people who have red-green color blindness. So I'll try to something a bit red. I'll use red for these negative points, like that. Be blue for positive points, maybe something a bit brighter, so that they're clearly distinguishable. You still have that connotation to negative with red. Again, then still add it without stroke color, so it's just these points. You could also make it a bit, or symbols a bit smaller. So I'm already thinking of the styling of this map. So now reduced size of these points, and we have something here. One thing to consider with this map, something that's a bit hidden in QGIS and something that's not often maybe considered enough, is you go to properties and symbology here. So this advanced and the symbol levels. So actually, for this point map, our interpretation of the map is also depending quite a lot on the order of these points, because there's a lot of them overlap with each other. They're at the same place. Like you see on the map, there are many places where there are no points at all, and others where there are many observations. So if we set so that, for example, positive values are drawn first, so then that sets them sort of to the forefront, and that now it looks like the center of Helsinki is actually quite positively viewed. And if we change that back to so now actually it seems quite the opposite. So this is the weakness of this simple point map that we are creating. So keep this also in mind as you create your maps, that this layer, this draw order of the layer itself is also something that impacts the map that you're creating. Okay, let's work on this layout at this point a bit. So I'll show you a few things. For example, how to do the inset map, some additional sort of features of this map that it's good to have here. So now we have our layout basis here. I could just add, I think this A4 is okay-ish for the shape of Helsinki. Now, without spending too much time fine-tuning the padding of these points, they may be a bit too big still and all of that. So let's think of what we need for this map. Always keep in mind sort of what do you need, what's the minimum thing that you need to communicate to the reader of your map. So at least we need the legend that explains this styling of these points. We can modify the legends features here. Yet we can keep the background, but add it a bit of transparency. Yeah, that's fine. We can fill up some empty space with that as well. Then we have a background map. So OpenStreetMap data requires an attribution. So we'll type that here. And the actual styling we used was by Carto, so we'll add the attribution there as well. Make it a bit bigger. I guess another thing we've add at this point is add also attribution for the data. So it's by GIS team. All right, so now we're getting there. Of course, a good thing to add here perhaps would be a title that explains where in Helsinki. But I'll show you actually how we can add another sort of instant map that explains also spatially where we are. So we use this dead space here in the dead right corner, lower right corner to our advantage. So we add a new map, floating map here, and then overviews. So QGIS custom overview maps. Say that we're drawing an overview bar map 1. So map 1 is the actual this big fit map that we're interested in. Map 2 is this secondary one here, this overview map. And it shows the sort of Northern Europe. There was things of matters of taste. So how much you want to sort of show enough for the read of the map to locate where you're working in. Or we could actually style these layers independently of the primary map, so we can actually lock the layers for the primary map. And then for the secondary one, we can move these from view. We update. Okay, now we have just the extents in there. Actually quite small. And then we can make that a bit more visible by increasing the size of this. Okay, now if we add a line to that sort of overviews, then it's sort of pinpointed in here. I think that's good enough for demonstrating how this works. So now we have a few new map features. So we have this data attribution statement here. And then we have an overview or inset map. So use these to your advantage. Then getting back to actually styling the map. So if you were now working for the city of Helsinki, you want to present something. So maybe this point map isn't your best option because it hides a lot of information. It doesn't really show sort of where to want to highlight where are the sort of positively viewed or perceived places, where are the negatively perceived places. So we might want to think of other ways of visualizing this. And what we'll do is to create a grid overview or a grid map where we count the number of observations, and then we score the places based on the positivity or negativity of how many observations there are. Let's start it off with the processing tool called Create Grid. It has quite a few steps. So we create a rectangle sized or maybe at a rectangle grid, and you can get the extent from, for example, extracted locations. So it's the bounds of Helsinki, and set horizontal and vertical spacing to 250 meters. So at a small grid, and one, and then now we have a grid that covers the bounds of Helsinki approximately, or at least the bounds of our data. Then using this grid, we'll count how many positive and how many negative points fall into these grid cells. And this is a bit of a long process. So we'll extract from the point layer points that are either of these. So use the tool extract by attributes. Using the extracted layer that we have prepared before. I would say that as if quality matches this value, and the value should be positive, then include it in the new layer. And then, of course, because all points are either positive or negative, so then the opposite of this matching feature are all negative, so we can set this as a create temporary layer on this. Now we have 2 new point layers, and this extracted attribute is the one that has positives on it, so we can rename it for our own benefit. Positives, and the other one has all the negative points, so negatives. Then we'll have to match these, or we have to sort of join these points to the grid that we created. And there's a handy sort of tool for exactly that, so called count points in polygon. So using the polygon layer as grid. And then first, let's add positives to it. Renaming the count field named positives, and other ones can be left empty. You can run it. Now we have a new layer called count, and if we check the attribute tables, and indeed, here we have each row will have a count of a number of positives that points that fall into it. And we still have the negative points, so using this recently created grid or count, we'll add the negatives to it, and this time call it the same, so negatives. Now we can remove this firstly count grid that we created first one, because this other one has both of these. So now finally we have grid field that has positives and negative points. What was processing prefacing step before I can get to stylization. So we want to keep only the grid cells that have at least one observation, whether that be positives or negatives. So we used extract by expression tool. And now using the count layer that we created, we can set an expression here. So this simply tells that QGIS to keep the ones that match this expression. Keep it in the newly created layer. We say that positives or negatives, and this sort of checks whether that row in the layer has either positives or negatives at all. So if it's 0, then then this expression doesn't match. But that's what we're doing here. Basically just run it and matching features. And at last we have what we want. So we have a newly created grid layer with counts of positive and negative observations. And we could do that. We could just visualize that. We have 2 maps, one with the count of positives and one with the count of negatives presented. But actually, we'll still create this score that sort of balances these positive and negative observations. So, because that's sort of easy and quick to interpret. You can read it more in detail in these instructions. I'll just show you how to calculate it. So on this matching feature, you can open the attribute table and then add complete calculator, add a new field or positivity core. This will be a decimal type field because it varies from 0 to -1 to +1. And then you can copy paste this expression in here. Yep. And now we have a bunch of scores that are sort of absolutely negative, and then these ones that have both observations, but they're leaning towards negative. And then the same for the positive scores, positive grid cells. Now then, you could create a map much like this one. You could use graduated symbology, positivity score. Maybe change. Just draw something together very quickly, and then get it here. Because I still want to show you how we can do a bit of labeling in QGIS. So that will be the final thing in this week's QGIS tutorials. So for the background map, we already have some place name labels here. Ones that mark these cities and ones that mark neighborhoods. They're not very visible maybe, but they're still there. That helps a bit on orienting our reader. But we'll use this explicit landmarks layer that we prepared. If you open it, you'll see that it actually only has 3 points that are sort of these landmarks or notable places in Helsinki. Helsinki Cathedral, Pasila railway station, and Itis shopping center. If you were to just enable labeling, so it's basic stuff you probably know it. So labels and single labels from styling. So it's not very good. By default, you don't really see anything in here. So let's work a bit on how to make those labels better. So first we can enable buffers. So that's this white buffer around texts. Then we can enable callouts, which is a cool feature. So you can see that it overlaps, these labels overlap with our data a bit. So with these callouts, we can move them around to a more suitable location. So if you enable them, and then you can move them around from this labeling toolbar. And if you don't have it on your own toolbar, in general, during these tutorials, if you see a toolbar or a panel that you don't have, so you can usually find them from view, and then toolbar, label toolbar. So we use the center one to move layers, labels. So now you can see that you can actually select these labels and move them as you wish. A bit away from the data just to demonstrate it. And you can sort of find suitable locations that you want. I still quickly show you another way to add labels to maps in QGIS. So since QGIS 3.22, you can also add annotations directly on the map layers. So directly on this sort of place here. So instead of having an explicit layer that sort of works as any QGIS layer, so you can actually find these annotations, and again, annotations and toolbars, annotations toolbar. I just show you that you can add, for example, a text annotation. So there's another shopping center right here. So we can add a pipe at that ready. Draw a line similar to the callout that we just made. Like that. It doesn't scale the same way, so it's sort of tied to this project and tied to this map screen. So we can still increase its size right here. Like 32, 6. Yeah, something like that. So this is an alternative way to add labeling to the QGIS project. So use it whichever you wish. Our label layout. We unlock the layers. Something like this. So if I would be advised to create another layout or with this as a basis, and then just like from layouts and duplicating this first layout and then working it so as to not lose this first one. But this is just to demonstrate how this might look. So you can see from the example instructions how you could keep working on this layout. So add a title, of course, add a scale bar, maybe a note arrow if you prefer. So think through these things. So there are some other points that I want to raise here earlier as well. So the color scale that I'm using isn't actually really great because it's supposed to show you sort of a move from negative to neutral to positive. So think through what would be actually a better way to show that information instead of this standard viridis. So even if I have it in the example map, I want you to critically think through what would be the best way to show the information that we want the reader to know. Okay, in the instructions, there's also a stretch goal. If you want to try out other ways to visualize this PPHS data, there are multiple. So one approach would be using heat maps. Okay, and that was the second week of tutorials. If you have any questions, please ask them on Discord or during class.